anyone on the shop floor can simply grab these robots, just like a trolley. Just grab these robots, make it move around on their shop floor, and in this process, the robot learns about your operations and can do it autonomously next time onwards.
Just a quick reminder for you to like, subscribe, and rate this podcast so we can get your feedback and know how to make it better.
Hey, it's Ari. Welcome to another episode of the Made in America podcast. Today, we're going deep Industry 4.0 with robotics. I've got Rishabh Agarwal, CEO of Peer Robotics. Rishabh, thanks so much for coming on today.
Thanks a lot, Ari. Really great to be here.
Well, listen, it's the Made in America podcast. So we start off with the same two questions, my friend. What do you make and why do you make it?
So we are a collaborative robotics company. We make cost-effective and simple automation solutions for manufacturers. And why do we make it is a little bit of my background here, essentially. So I come from a manufacturing family, like my brother, my dad, my cousins, my uncles, the distance family as well. Everyone is manufacturing, from car radiators to aluminum extrusions to corrugation boxes, you name it. So we grew up watching this, right? Like as a small kid, I was with my grandfather and father, like in the facilities, understanding what are they doing, right? So it was always a fascination that how complex that manufacturing space is and how much it actually needs from you to build something, right? So yeah, that always interested me into that space. And as I grew up, I did my studies around, realized how automation can really change the lives of these manufacturers. Mm-hmm. It became like a passion for me. And that's why we are here. Like we are building something that can solve the problem of today for these manufacturers from across the scale, from a small scale manufacturers to a large scale manufacturers, how we can add value. And that's what Peer Robotics is doing.
Oh, that's awesome. Great answer, by the way. Concise story. Seems like you practiced that before. I appreciate that.
Appreciate it.
Yeah. So listen, I definitely want to get into it. I think we've talked so much over the years. We've been doing this podcast and with so many different manufacturers in so many different ways about Industry 4.0 and about robotics and about automation. And I think it's pretty clear to manufacturers that have been around that automation and investing in technology is the only way forward, right? We don't manufacture the same way today that we did 10 years ago, let alone what we did 50 or 100 years ago, right? Things move on. And I think it's really exciting to be talking to somebody who's sort of on the forefront of driving that. So we've got a lot to talk about in terms of, how you got started, what the value proposition is, how you work with customers, what your robots do, and all that. But I think you sort of started with your background, but I'd like to kind of dig into that a little bit more. So I think, it's definitely fascinating. We heard a lot of people who've been on the podcast that have talked about a family history of manufacturing, but they're generally people that have been from here. And I think your accent belies the fact that you're not from here. So where are you from? And give us your background about how you got here.
Absolutely. So I'm from a western part of India. It's actually a desert state. Like it's like a full-on dry state, probably similar to Texas, I would say.
Okay.
But essentially grew up there my entire kind of childhood. Again, as I said, like entire family was like a joint family, which is like my father, my uncle, my grandfather, everyone is in the same house, like a big house.
Really?
Yeah, everyone is in the same house. Kind of related businesses, but not the same. Like everyone is doing something of their own, right? So grew up around a lot of people.
So you have a manufacturing and an entrepreneurial background in the family.
There
That's
you go.
all coming together.
Yeah. So it's all like, I think, side story. When I was doing my PhD, my grandfather was like very sad. I was like, that's not how we do business here.
Really?
Like, you got to do manufacturing or you got to do something in business, not PhD. Like he literally told me that, hey, nope, like book reading is that's it. We don't go deeper than that. Do something of your own now. So
really?
Anyways, yeah. It's like so that keeps me on track as well. Like the family in manufacturing and business keeps me on track because they give me a focus that why we do this and we do this for everyone around us. Like we have the focus there. But yeah, long story again, like back on track. Did my bachelor's in mechanical engineering. I was the first one to get specialization in robotics from IIT Delhi, in Delhi, like India's capital essentially. Came to DC for my master's in Maryland, College Park, and did my master's in systems engineering while kind of focusing on human-robot collaboration. So that was an area, or that was the time when I started working on technologies like haptics and essentially how we can enable robots to understand what they're picking. So we
Almost give them like that. Almost give a robot the same feel and touch, right? Like
sense of touch.
right? Like
Yeah.
when we grab something,
Yeah.
we sense that we're holding it, so we can grip it and move it on.
You nailed it.
But typically, historically, the robot would have like a coordinate of some kind, and that becomes a real problem if the object isn't in the exact same place.
You just summarized my thesis around
Oh,
it. So that's exactly what we did. So our whole idea was that how we can build these sensors that can be easily added on to existing robots, and these robots can now enable picking up different objects without even looking at vision. Because if you think about it, we as humans don't actually need to see the shape perfectly well before we start lifting them up, and we don't even know the weight.
Yeah.
Robots need all of that right now.
Right.
So we do it dynamically as we are picking it up. We know that, oh, it's heavier, so I will change my force right there, right? And that's what we were doing. And as a researcher,
Really like interesting, detailed thing that I've never really thought about, which is it had occurred to me that a lot of times when we pick something up and we've got these mugs in front of us, so it's easy, is you glance to sort of get generally where it is,
Yeah.
but then you really rely on your hand to sort of do the last little bit, right? Your eyes get you in the general area and your hand gets there. And then to your point, you have some memory, like I see this cup is roughly half full, and I generally know how heavy a half full mug is and give it the force. But every once in a while, the mug or the bowl is heavier than you think, but you sort of in almost a split second adjust.
exactly. Yeah.
But a robot in theory would have been pre-programmed. So if the weight is different, it's got a problem. So you're not only giving it the sensory touch, but then reacting to what that senses are telling you.
Exactly. So now what happens is that there's this school of thought, right? When we build robots, why do we build robots that are so different than humans? The whole concept is that we think of machines as a fixed input machine, right? Like you gotta tell them exact weight and then they will work, otherwise they won't work. But we humans work on relative kind of phenomena, right? Like we make an assumption, we do something and we correct ourselves and we constantly correct ourselves till we achieve that task. And I think that's where the field is going now, where we are trying to give robots the sense of learning, right? And that learning is by making mistakes same like us, like humans, right? So that was my thesis. That was something that I built. And then I moved on to do my PhD in Germany. So I started working with Siemens. And along with that, I was doing my PhD in Germany. And that's why Oktoberfest and all.
Clearly a gentleman of the world here. Bachelor's in Delhi, master's in DC, PhD in Munich.
I didn't complete PhD though. I
You did?
dropped it. yeah. So it was after some time I realized that, okay, the work that I was doing was on from sensors to actuators. We were building muscle actuators. So now we were at that stage in Siemens where we were doing some research work that would enable kind of new actuation systems for these robots, but it was still very early on. Like I would say 10 years like later, we might have a prototype that we can show something.
Got it.
But that was the time that I also wanted to do something of my own and figure out what are the problems that
When
customers have.
your grandfather's words were
Exactly.
coming in.
Yeah. They were back in. Like I was like, okay, yeah, he's right. Like I got to create value today. And that's why I kind of moved back to India, started building on these technology, which is Peer Robotics, what we are doing. And since then it's
been a whirlwind.
Right
So, and I'm going to ask you about your then trip back to the U.S., which I know a little bit about, but looking forward to hearing more. I just want to take a step back, and I just wonder, when you were a kid, before you went to do your bachelor's or your master's, like were you into video games or computers or like what? I mean, I guess there's two questions. One is, how did you even know about robots? Was this like, man, I really loved Star Wars or whatever and thought, wouldn't that be cool? Was it something you learned about in school? Like, I'm just curious, what was that initial spark that gave you the interest?
So I would say it started from machines in general. Like even right now, like if you say we are a robotics company, but I don't think robots are anything different than tools.
Mm-hmm.
It's exactly the same thing. We are just advancing our level of tools, kind of, right? So I was always fascinated by different machines, like going back manufacturing industry. So I was playing around with different machines that my dad had, like in the plants. And it was fascinating, right? Like how complicated they were. Like it's just crazy that you can give them power and they would do those things, which if you think about doing it by yourself as a human, forget about it. We'll be making one part in 10 years right now, right? So that always fascinated me. And that's why I took mechanical engineering, because it was like, okay, these are machines and I want to build machines. But as I went deeper into the machine side, we realized that The new era machines are general machines, which are robotics, right? That how robotics is going to kind of enable more levels of automation or machinery and give better tools to the humans. So in my mind, there is no difference between robotics and tools.
So I mean, I think I'm just repeating what you said, but you're just looking at robots as the natural evolution of the tools of manufacturing, right? So just like we might think if we took someone from like 1890 and put them into a factory of today, they would be like mind blown about how far things have come, right? And just similarly thinking, well, we're going to keep evolving, and the robot is just the obvious next step.
Exactly.
But can you just elaborate on sort of the why behind that? Is it because the robot can do so much more, or like why is it? I guess to a lot of people, even myself included, it feels like for a long time the machine improvements have been like evolutionary, right? Like if you think about like an old Bridgeport or an old lathe, and you think about a CNC machine, it's you could sort of see how if you put them next to each other, you sort of go, oh, I see how that kind of happened. But in my mind, you put the robot at the end of that, and it's like, what? I don't even know where that came from. Is that just a misconception on my part? Do you see that as just a natural evolution, or is this sort of a revolution of something totally different? Like the difference between the old days where you might have like a water wheel with one, like, I don't know if you even know about this, but it used to be where there'd be like one drivetrain through the whole factory. You hook up your machine to the drive, and they would all be sort of driven, and then we had individual power. I mean, is this that level of like revolution, or do you see it as just a natural one little next step?
A little bit of both, I would say. So I think there were two things that happened in parallel that enabled robotics. One is definitely computation. That as we became more sophisticated and we discovered kind of computation in general, right? Computers and all these machines, that gave these machines a sense of knowledge, right? Like it's rudimentary, like PLCs, right? Like I would say PLC can be a one step or older generation of now robotic systems, right? It's like a programmable logic controller, but it started enabling something which can mimic almost what a robot does, which is, okay, if I get this, then do that, right? Like if a sensor gives me some value, then I'll take this action. And we started detaching it from the machines that it was part of and making them a part of their own, or like an individual system. So I see what we were able to do is that we took components of the existing machines and we brought them outside, and we kind of made a bit more general system. Now it's not perfect, and that was the caveat, because when robotics first came across, they were trying to do a bit more complicated things that machines used to do. But that's not how robotics can function, because if you do a lot of things together, then it's bound to fail. Machines have a very simple task, one thing that they would do 100% precise. Robots don't have that right now, and that's the direction we are in. That okay?
Well, let's dig on that for just 1 second.
Yeah.
So you're saying people are trying to do too much with a robot
initially? Yeah.
Give me an example.
So let's say if we are building manipulators or mobile robots that we do, mobile robots are something that we focus on. And if we go and talk to someone who are doing some automation systems on these robots, they would be like, okay, nice. Can we do, let's say, pallet movement with these robots? Can we do a bin movement with these robots? Can we do trolley? Can we do X? Can we do Y? Like they're like
scope
a list
creep.
of things. Yeah, scope creep, right? Exactly. And that's how most of these systems started building up, that, okay, let's build a more generalized solution that can do a lot of things. But in the end, people realized that, okay, let's narrow down a little bit more. So now there are companies that specialize in welding, right? They have welding robots that are kind of way better than the machines that were used before, or now they're way more accurate and safer, right? So now they're pick and place robots, which are focused on just that particular operation, right? But they're precise, they're correct, they're value add. And there are a bit more general platforms, and they're becoming more and more common with ChatGPT and some of those other kind of new era computational advances we are seeing. We will see more generalized platforms coming back again. But I think it's like a seesaw kind of progress. Like we did general, we're like, oh no, let's focus on like one thing at a time. And then now we can increase the scope slowly.
So when you look at a pick and place robot, I think a lot of people maybe have seen that, right? Just like an arm with a little picker at the end that just essentially, just like it says, takes something from one place and puts it somewhere else, sort of like getting rid of that sort of repetitive motion. Does that meet your characteristics of sort of like a robot? I mean, because you sort of added something in which I thought was interesting, which is like the thing can learn on its own, and doesn't sort of, my impression, it doesn't require a ton of extremely precise setup for the thing to do what it needs to do, right? So if I got a pick and place robot and you're like, well, it only works if you put the pick stuff in exactly the right place. And if it's off by 2 millimeters, that little picker is going to miss and then you've got nothing. Like, does that meet your characteristics?
I would say that's more of a machine.
That's what I'm driving at.
So I would still categorize them as a machine. And that's how you can see that the distinction between machines and robots is just that learning aspect. That now can they make a decision on their own based on some of the feedbacks. And this feedback, by the way, can be environment, can be other humans, can we learn from the humans in the environment, right? But you're right. So in my mind, if something is fixed, rigid, it's more of a machine than a robot.
Got it. I love the definition. All right, cool. So we can geek out back more, but let's kind of jump back to the story and say, you ended up coming back to the U.S., ended up in Connecticut. How did that happen?
So when we started working on this technology, we got connected to Stanley Black & Decker and Techstars program. So we met some phenomenal folks around. I mean, you might know Mari Gui. Like phenomenal person,
sure.
right? Like he's one of the persons behind the Stanley Black & Decker and Techstars program. He, I would say, supported us from the early stages, like whether it's connections, whether it's understanding, whether it's go-to-market. Mari was always there, and it's still here, by the way. Like he's still like, whenever we give a call, Mari is always there. Right?
Always.
Laila, like I don't know if you have interacted with her, but she was part of the Stanley Black & Decker program. Phenomenal person to support us in the business side, in the startup world, like venture capital, startup, everything. So we got these folks around that really were enthusiastic about what we are doing, and they were involved in helping us out. So what they did is they did this program in Hartford, which is like Stanley Black & Decker Techstars program. And as part of that program, we got a bunch of mentors around the area. So CCAT was part of that. I think Advanced CD was also a part of that interaction early on. Stanley Black & Decker, their entire team, right? And several connections from that area, right? Connecticut Innovations. So we started interacting with the ecosystem more and more, and we really understood that the market lies in small to medium scale manufacturers. Like they're really struggling. And it took me back to my days, to my family, and understand that, okay, yes, like how they were operating and what are they having right now? What tools do they have? And once we started going deeper into that particular market, we saw that if we take 10, 20 years, bigger industries or several different areas like IT sector, banking sector, they had drastic changes that happened, right? But after that industrialization era, the SMEs are practically still operating in the same approach. Now they're getting better operations, they're getting better tools on the software side. But if we go back into the machines or the physical operations, they're still having to do the rudimentary tasks that no one wants to do, right? And it's more difficult for small manufacturers because how would they convince someone to join their company where doing the base task, like bare minimum, when that same person can join a large enterprise, do the bare minimum and grow to that scale, right? Like they have the more growth option around there. And that's what kind of like brought us to Connecticut because aerospace manufacturers and the number of SMEs around this space is enormous. Like I think in America alone, 95% or 90%, somewhere around that, are SMEs.
Correct.
That is manufacturing. And Connecticut also leads in that same chart. And that's where we saw the potential of the market and really the need of a solution that is simple and cost effective. And that's why we're here. Yeah, New Haven now.
That's a good answer. So I think a lot of folks in that SME space don't believe, don't understand that they can do it. Like it just seems like a big lift, or at least that's what I've heard. Do you see that? And how do you feel? What do you say in response to that?
Correct. Yeah. And it's true. It's true. Historically, if we bring some new machines like these, which are complicated, you would need software engineers or you would need specialized trained individuals to work on these systems. And the manufacturers have the right perspective there. Like they are worried that I'm taking a rudimentary task, but replacing it with a more complex task that I don't even know how to handle.
Very high paid people that need to then manage it, right?
Yeah. So that's a legit fear, right? And what we do about it is that we have built these systems that can literally roll in and start working within a day. So what we want our manufacturers is that it's okay. You don't have to buy systems. You don't have to do anything. Just come and play around with this system. Just deploy it on your own. If you like it, you take it. If you don't like it, that's fine, right? Because we got to give them that interaction. We got to allow them to interact with these systems, learn more and understand the potential and understand where the technology has now been, right? Like they've been out without automation for such a long time that that's a fear barrier. That if I do that, what's going to happen? So it's important for us to kind of enable them experience it. And that's why now at this point, what we are focusing on is bringing our platforms in different innovation centers and bringing manufacturers there and have them experience these things and play around with these things.
And how's it? So we really haven't talked about is what does your robot do? So let's kind of clear that. So you guys have come to market with the first product that you want people to try out. What is it?
Yeah, so it's a collaborative mobile robot.
Mobile robot.
Exactly. So what it does is it's a material handling robot that can move bins or trolleys around in the shop floor. But the key part is it understands humans' haptics. So going back to my research area, what I was working on is how to make robots learn from humans. So essentially, rather than having those complex level programmings or individual to train the robot completely, anyone on the shop floor can simply grab these robots, just like a trolley. Just grab these robots, make it move around on their shop floor. And in this process, the robot learns about your operations and can do it autonomously next time onwards. So let's say if you have a particular flow of material, you just teach the robot that this is my point A, and now we follow this path, and this is my point B, and you just got to do it 10 times, 20 times, or in a loop. The robot can autonomously do it next time onwards. So the person who was taking care of that movement back and forth, every 30 minutes, back and forth, doesn't have to do it. They just teach it once. That same person can teach the robot, and the robot can take over that operation. And that person can now focus on machining or manufacturing. What is their core kind of, cognitive abilities that they're using?
So does it go on to an existing trolley? Is a trolley part of the robot? How does that work?
It can do both. So yeah, it can pick up a trolley that is existing there. It can use customized trolleys as well, that you can just increase the height of the trolley so the robot can go underneath it and tunnel it out. It can use your existing bins. So how we have developed these platforms is the mobility aspect is the base. And on top of that, it's a personalized solution for the end user. So if they want to have a conveyor top, they can build it on top of the robot. They can have these bins picked up from those conveyor tops and dropped into that other kind of production line or other zones.
And so does the robot itself go and fill the bins, or it just moves them around?
It moves them around.
So it would go back. Someone has to be there to give it whatever it is.
It can pick up the bin.
Okay.
Yeah, but it can only move it and pick in and drop in. So
say again. So it goes to where my normal bins are.
Yeah.
It can pick it up and add it to the cart.
Correct.
And move it over and then drop it off somewhere.
Exactly.
Oh, so I don't need someone to be there to take it off. It can drop it off for you.
Yeah. It can feed into those production lines directly.
Really?
Yeah. So they're flow conveyors. And a lot of these things, by the way, existed in manufacturing for a long time. So every Kanban systems, right, where the manufacturers have that, okay, I have 3 empty ones, 4 filled ones, and I know this is the production, this is the part I'm manufacturing. So these robots become a part of that Kanban system. So they're feeding those Kanban racks essentially, right? They're going into the storage, picking that bin, feeding it into that Kanban racks, bringing the empty ones back to the storage, and closed loop.
Really?
Yeah.
So then you see, here's scope creep, right? So then does it know to say, hey, like we need to reorder because we're running out? Does it?
It can talk to your WMS and ERP.
Really?
Yeah. So it is integrated on open API architecture. So that's the learning part now, right? Like it can communicate and it can get that data and it can use that data to take actions. And that data can come from MES systems or ERP systems that right now this part will go to X production line or 4th production line, something like that.
So let's get back up to the learning component. So I want to try this thing. How do I teach it?
So let's say whoever joins your facility, you would show them your facility first, right? Like, hey, this is how we work. This is our pickup zones. This is our drop zones. You got to work on producing or filling.
This is like somebody from Peer Robotics, you're saying?
No, I'm saying anyone who joins your facility.
Yeah, of course. Any new employee, of course.
A new employee, you would kind of show them how the operations happen.
Yeah, right.
So you do the same thing with the robot. So you grab the robot physically, like it's like a trolley, right? So
Yeah.
you grab the robot that has handles around there.
Okay.
You grab the robot and take it to your pickup zones. You tell the robot, this is my pickup zone. You grab the robot again and you take it to their production lines and you tell the robot that this is my production line 1, this is my production line 2, this is my production line 3. And that's it. So next time onwards, whenever the robot will receive a command, whether by you in our dashboards or something, or your ERP or MES, that take from pickup and drop to production line 2, it knows, it already learned it from you, that which one was the zone and which one was the path.
So what happens when it's going down the path and somebody left something in the way or whatever? Yeah.
So the robots are integrated with LiDARs and cameras. So what the robot does, it constantly monitors its environment around it. So if it sees something in the path, it automatically detects it and creates a new path around it. So it avoids the objects and kind of replans these systems. Yeah. So you
Sort
don't
of
have
like
to,
a Roomba.
Kind of. Yes. It's a very simple, it's a Roomba to move heavy material more accurately.
Right. Interesting. Why was, I mean, I guess it could be any number of things, but like, was there a particular reason that you felt this was the right first implementation for Peer Robotics?
Lowest hanging fruit. This is the task no one wants to do. Like no one. Like we haven't met anyone who says that I love this moving around card.
No one likes being a gopher.
Yeah, exactly. Like no one wants to do this task. Like whether we are talking about manufacturing, whether we are talking about warehousing, no one wants to do this task. And what ends up happening is there's a shabby work that happens here. So a lot of production lines would face challenges because simply the line was not fed on time. Right? Because they were just waiting for some components and, oh, well, now I got to go and bring it. And those are downtimes, right? Even if it's 15 minutes of downtime from a production line standpoint, it's a huge loss for a manufacturer. So that was the key part, that this is the lowest hanging fruit. No one really wants to do it. Can we start implementing it and see how we can scale different solutions from there?
Yeah, so I found an opportunity where no one wants to do it. It's important that it gets done. And if it doesn't get done, it costs money, or maybe said differently, if it gets done consistently and accurately, it's worth money.
Yeah.
So those are pretty good system components for you to pick a place to start.
Exactly. Yeah.
So can you share, and I know it's probably difficult to say customer names, and I won't make you do that, but what can you share about specific implementations that you guys have done? I'm just curious.
No, absolutely. And I mean, so we work with different automotive industries, electronic industries, and most of the time the implementations are towards assembly lines. So these are lines where a lot of different components have to come together and someone would assemble that, right? And most of the places, it's still an operation, it's completely manual. Like we are talking about person looking at, okay, what are the SKUs I have to make and what are the components associated with that? Go bring that component and start the assembly process. Mm-hmm. Or someone is just focusing on moving the material between them, right? So these are the only two ways the operations are done right now. Now, what our robots have done in these facilities are two-way. We have one solution that can go and pick up a complete trolley. So you can think of it that in a storage, someone would already stack up an entire trolley saying that this is the trolley for production line 1 or this is the trolley for production line 2, which is raw material or components that are going to go in assembly. Robot will go around, autonomously pick up that trolley. And to your point, even if you move the trolley a little bit here and there, it's all around, it's perfectly fine. Robot still uses its cameras and LiDARs to automatically detect those trolleys. So that's the cognition the robot has on itself. That's the correction it can do and enable kind of seamless operation for the end user, right? So it will go on, pick up that trolley. It actually literally goes underneath, picks it up and brings it to that kind of production line that it was supposed to go and drops it and brings another one, kind of goes back to the pickup. So that is one implementation we did for an automotive industry. The other one that we worked on and deployed kind of multiple robots in that same space was for electronics industry, where there are now two problems. You can't really touch a lot of those components because of the EMC compliance.
Sure.
You kind of destroy those resistors or several components that if humans touches, like it has to be very careful. In this case, it's completely like non-touched components that are being moved by the robots. So there are these flow racks where someone from the clean room area who's already there, who don't step out on the clean room, they already stack these materials, put them in these totes, and in these flow racks, it's there. Robot goes, autonomously dock itself to those flow rack that you taught, by the way, that this is my flow rack, right? It docks itself accurately with the accuracy of under half an inch. It goes and docks itself, and the bin kind of goes on the platform, and it goes and feeds to that production line, brings the empty one again from there. So that's like another implementation that we did. Now we are working on several other solutions as well for industries like manipulation, mobile manipulation. So you can think of it like base robot with a manipulator on top of it. So it can service multiple feeding of CNC machines. If they want to replace components, if they want to replace the tool, these robots can go and do that. But that's a little bit more on a development project for us at this point.
So now here we go with the scope creep, right? Before we're moving stuff around, now we're moving it. We're going to add the arm so it can actually do something when it gets there.
But that only comes after we have successfully kind of enabled those first two applications.
Right.
And now we know that, okay, what all value we can add to our customers. So this is another area where they would need more solutions on.
So where do SMEs get in? Like, let's just take a step back. Most of the manufacturers you mentioned are small manufacturers, right? 20 employees, 30, 40, 50 employees. How would they ever get started? Like, I think everyone's sort of generally interested in the concept, but the hurdles to get started, we've already enumerated. So if someone came to you, let's say I'm a small manufacturer, and I'm like, Rishabh, I'm interested. Where do I start?
So there are two things, right? Is the cost, first of all, like what is the upfront investment that I would have to do, right, to get started? And the other thing is complexity, that how much time is it going to take to make sure that these robots are up and running, and when can I start seeing the value add, right? So how we address those two challenges is with the cost side. First of all, our platforms are designed to make sure that we can provide fast ROI. But even on top of that, we have robot as a service model, where essentially the users can get these platforms on a rental basis. So rather than buying them on a capex, they can lease out or rent out these platforms for a period of time, and they can start using these platforms from day one, right? They don't have to give any upfront cost on top of it. The second thing, which is the complexity part, we already discussed that how simplicity allows our platforms to be up and running in a day. In fact, most of our deployments that we have gone into, in 2 or 3 days, the robot is already adding value to their operations and their team is kind of using it. And that's what we want. Like in first month, just use it, start working on it and see how it moves around, how it adds value. And most of the time, what we have seen is increasing the number of robots after that.
Really?
That, okay, this works, that, okay, how we can add more platforms. And then it becomes like a little bit more kind of long, or I would say large timeline project, where we are trying to understand all the kind of different solutions they would want, all the things the robots would want to do. But at least for any manufacturer who is just thinking about going into that space, I would recommend start extremely low, like just one platform, just understanding what are the key value add operation. What is the biggest problem? That is the lowest hanging fruit. That identifying that problem is critical, because the projects that we have seen that failed were mostly because there was like no clear understanding from both point of view that what is that lowest hanging fruit. Because if we are not able to identify that, the ROI won't come. Right? So now it's not that the technology doesn't work or the pain point was not valid. It was just that it might have needed more time to reach there.
Yeah. So find something that's sort of more the most basic that adds some value.
Yeah.
And so just thinking, if I'm sitting here and listening to this episode and I'm in my manufacturing and I'm like, I don't know if I have an application for this robot. What is the application? Like, what would I think about to go, oh no, I could try this. Like, is it anyone that has any bins? Like, I mean, what is the, you know what I'm saying? Like, what's sort of the basic? Yeah.
So absolutely. If someone is moving material a lot, someone is doing any form of assembly around here, it's an application for them for sure. Because
just like everybody?
Yeah, mostly, right? Like especially in aerospace, right? Like there are some process industries for sure, like food industries and all that might have just like a complete one feeding and then after 1 hour like dispatch kind of from the end of the machine, right? Those industries might have less frequent movements, and that's fine because then you are talking about once in a shift. And I don't think automation is anywhere justified for that, right? So if you're moving material frequently, like at least once in every 30 minutes or something, right? If that is happening, these robots can help, right? And that's how we should start. Like, okay, is that the operation? And can the robots start doing something which is at small scale, but we can see value and then we can grow from there.
Perfect. So when you got started, and you spent some time R&D, and then you got some stuff in the field, what were some of the lessons that you learned early on that like surprised you?
the first thing was like I had to switch from engineering, building cool stuff, to understanding user pain point. So I think that would be the hardest thing. And even right now, like we have most of
Your
our team
grandfather
members-
again.
Yeah, right?
Get out of the theory, Rishabh.
It's like, what is this? Like all lost books kind of thing, right?
Right,
like where
right.
the money is going and not profit coming along. And I was like, oh yeah, because we're building stuff. It's like, how long are you going to build?
Right.
Like anyways, so it was like one of those things that we were trying to understand that initially we started building some things, some features just because like, oh, that would be cool, right? That would be cool.
Right.
People would want it. We didn't validate it. And that was like the biggest learning in the journey of the startup, I would say, right? Since like right now where we at is understanding, first of all, what do users want? Every manufacturing is different. And it's important to understand that what are their real pain points versus what they might feel or what we might go and push for the pain points, right? So that was something that we learned in a kind of our sweet time, but we learned it, right? So another aspect that you mentioned that, as we were talking about it, the scope increments and all, started learning to say no. Right? Like, and that was initial first two projects I remember. If someone would say, can you do this? It was like, we are engineers, we can do that. We'll do it. And by the way, we can do that. Like that was never a question as well. Like we can do that. But was it worth it, the time investment and kind of output for both the parties, right? And it's important to do that evaluation and understanding and say no sometimes that yes, this might be possible, but I don't think that would be a right thing to do at this scale. So let's touch base after some time, or let's grow it when we have kind of like a clear perspective and understanding that our technology can do this, right? So that was important. And we ended up projects where we were like complete mess because we didn't say no.
Yeah, no, that's a very, very important lesson to learn, and one I had to learn myself in business. I used to remember thinking, given enough time and enough money, I'll put a computer on the moon. But then the question is, do you want a computer on the moon? I'm not really sure that anyone really wants that in the end. It sounds like you've been down that road as well.
Yeah.
What do you see as the next steps for Peer Robotics? Like, I mean, you're still really in startup mode. I think you can correct me if I'm wrong. Yeah. And so do you have that sort of, are you at the place now, and I'm going to put words in your mouth so you can give them back to me if you didn't like them, but that you've understood that the focus needs to be, aim small, miss small, aim at something we can actually achieve that drives value, and just rinse and repeat and really get adoption? And is that where we are? Are you thinking about evolving to something else? Like, kind of where are you in the journey?
So we are all customer focused right now. So from that perspective in our journey, we have a technology, we have product, we have kind of several certifications and proof of concepts around there that how this technology can work, and active customers that are using it globally, like US, Germany, India. We have customers in all three geographies, soon in Hungary as well. So that would be also an interesting country to visit. But at this point, our focus is to talk to more and more customers, more and more manufacturers, understand their pain points and solve that. It's a very customer-centric stage of our journey right now. And we are still at that startup journey where we are listening to our customers, understanding what all we can do better, both in technology and our business models. How we can make RAS better, robot as a service model better, how we can make adoption better. We have partners now, which are system integrators, local system integrators who were already working with these manufacturers for PLC or conveyors. Now we are starting to work with them, and they adopt these technologies and deploy it for these end customers. So we are seeing gateways and we are seeing channels where partnering with partners or companies can enable us adding more values. So we are in that journey where we are listening to customers, we are listening to the ecosystem, and taking action to make our product more aligned and our business model more aligned.
Good place to be. What should manufacturers, from your perspective, what should manufacturers be doing or thinking when it comes to investing or contemplating use of robotics?
I think one thing I would say that every manufacturer should definitely think about is that automation is no longer kind of long-term thing. Like we have to start adopting it today, especially as we are bringing manufacturing more and more back to US. And that's what's going to enable that, which is automation. Like if we have to compete globally, it has to be automation as part of the manufacturing. Like if we look into it right now, the number of robots globally, China is the biggest importer of robots. It's the biggest importer of robots globally, more than 50% at this point. And the fact is that even though there was manufacturing kind of people were there were no labor shortages around there. Like, you can't rely on that for long term, because two things. One is people will stop doing those operations because they don't want to. Their children and all, they don't want to do those operations. So they will train them and they will give them a better life, which they should. And then the second thing was that you won't get the same quality output again and again. So automation is something that we have to adopt right now to bring and manufacture more. And one thing that I always say is that it's not about less jobs at all. Like, automation enables more jobs. Like, automation absolutely enables more jobs, because we are just increasing our consumption globally, right? Like, we are seeing in India as well that how manufacturing or manufacturers in that low wage labor countries as well are adopting automation, right? And these are large enterprises, granted. Like in India, we are seeing mostly large enterprises starting to adopt technologies, but SMEs now have the tools to kind of pick up a fight in this game now, which is with automation. Like, if they have to compete with them, it's via automation. And I think that's a good tool to have by your side.
Dude, amen to that. I couldn't say it enough on my end. We've got to adapt and grow and innovate, or we're going to fall behind. I mean, we can look at the history, if past this prologue, we can see manufacturers that didn't adopt and didn't adapt aren't with us anymore. And, there's always that sort of that challenge where when you were the young upstart manufacturer taking over from your dad or starting anew, you did something different. But now, once you've been doing it for a long time, you get stuck in your ways. We got to do something different. So I'm really glad that we had the chance, Rishabh, to get you on, because I think it's really important to get that energy and that excitement. And we certainly wish you the best of luck and look forward to watching you on your journey. You ready to wrap up with a few last questions?
Sure. Yeah.
All right. If you had to do something other than be the CEO of Peer Robotics, what would you do?
I would be an engineer here.
Engineer.
Yeah, for sure. I would start building the cool stuff again. I have to keep that part hidden for long. So
building cool stuff. I love it. Do you have a favorite business book?
Oh, E-Myth.
Oh, it's a good one.
Yeah. So I think I would say that was one of the first books that someone recommended to me. And it changed my whole perspective. Like, right now, a lot of my friends or people that I know are starting businesses, and they always come back and say that, do you have any tips around it? This is just read this book. Just start with that. Then Crossing the Chasm. It's also an interesting one. Have you read it?
No.
So this is like a kind of, I would say, a little bit more on the startup side of things, but it's about finding out that product market fit, working with innovators, working with adopters, understanding their pain points. The same stage, I would say, where
Crossing the Chasm.
Yep.
Who do you know who it's by?
No, I got to check again.
Crossing the Chasm. Good enough. That's awesome. I think I know the answer to this, but when you take time off, are you more of a staycation guy or an exotic destination?
I'm mostly at somewhere exotic anyway, so I spend time there. But if I get a chance, I would just be at one spot.
Yeah, I sort of thought that because you're traveling a lot. Sometimes you want that. Rishabh, what's something that you learned when you were younger that you think's really pushed you to the success and the journey that you're on now?
It's a deep one. So one thing I think, again, grandfather comes back, right? One thing he said early on is that listen to everyone, make your own decisions. So that was something which was very critical as part of my journey from the start, because when you're part of this household where a lot of people are around there, when you grow in a startup economy where you're seeing a lot of things happening around you, right? People raising a bunch of money around, and you want to help manufacturers, and you get very kind of different perspective on what do they want, how do they want to scale. I think one thing that keeps me grounded and gives me direction is that I take all that feedback, but I would in the end do something that I'm more aligned towards. So let's see where it takes me, but yeah.
Amen to that. And this is going to be a tough question because you're early in your journey, but I ask everybody this and I will ask it to you is what's something that you've learned later on in your journey or your career that if you could go back and tell yourself early in the process before you got started, and that if young Rishabh then would listen to you, that you feel like there'd been advice that had been really worth his time? Humility and patience. Humility and patience. Yeah. Can you elaborate?
So I think the biggest thing as I started forming a team, I had no idea how. So I always talk about it, and this is on the sideline. I was talking to one of my mentors. I never thought the human aspect of building a robotics company would be the most difficult aspect of building a company, right? I thought it's going to be a technology, but no, it's like different team members, understanding their pain points, also growing with them, making sure you do right by them, right? How to grow as a team. So this is not related to robotics or manufacturing at all, but that's where I started learning that, okay, how you form a team, how you kind of understand people's motivation and how you align them to the company's motivation. And I'm still in that journey. I'm still learning about that. Going back, how do you listen to customers with a humility is not to solve nothing, just sitting there and having a conversation to understand their pain points. Whether you can help or not, it's a secondary thing. But having a sounding member who is listening, who is understanding, I think it's good both ways. So, yeah.
That's really, really good advice, Rishabh. It has been really a pleasure and inspiring listening to you. It's I'll share this for someone that's been on their own business journey for quite some time. It's always really refreshing to talk to somebody kind of on the earlier stage, and brings me back to when I was getting off the ground and the energy and the excitement. It's really great. And I'm so appreciative of you coming on board. And as I said before, wishing you all the best of success, and I'll be rooting for you.
Appreciate it, Ari. Thanks a lot for having us here and really appreciate all the support.
Made in America with Ari Santiago is brought to you by Compass MSP.
Thanks for listening and spending some time with me today. My goal is to help build a strong manufacturing community, and it would be impossible to do without all of you.